I don't have intro video. What do you mean? Oh, there you go. Right. So now we are live. 8 seconds. Now I'm going to share my screen straight away. Good afternoon to everybody. So this is Mom Debbie again. I'm going to talk about inflection critical points of curves, which we did not do last midterm. So this is also a very important topic that we have to include, and this will be the first topic for finals. Okay, so as you can see here, it says critical points and inflection points are very important for analyzing behavior of a function. Now, for critical points, you have to, let me just emphasize some words in here. For critical points, then you have to take the first derivative. For the first derivative, you can get the maximum and minimum or saddle points of your curve. We have been doing curves before. We're drawing them, we are or illustrating them, we are putting tangent lines, equation of tangent lines, and all. Now, after that, inflection points as well. So we can determine this one through a second derivative. Now, I have here an example where it shows you the minimum point, which is the lowest part of a curve, the maximum point, which is this is the minimum, this is the maximum point of a curve, the minimum as well, and inflection points. Inflection points means that is the point when the curve changes from maximum to minimum. That after your -1, this goes down already. Okay, so from -1, it goes up to the maximum, and from positive going up again. Okay, so inflection points will tell you when the sign changes from positive to negative or negative to positive. So for example, the positive one in here, this will be an indicator that when you're above or beyond your inflection point, then the the sign becomes positive because it's going up, and when you are below positive one, then it goes down. Okay, so inflection points would illustrate concave shapes. So we have here a concave down shape of inflection point. When it's flat, then it means that when it's flat, it means that the slope is zero. Okay, let me just write that in. When the slope is zero, hang on. When it's flat, the slope is zero. What is a slope? The slope is either an m, or it is your dy over dx, or this is f prime of x. All right. So if you have an fx, therefore, or that is equal to y, then if you get, for example, you have 3x squared minus x plus 5, and if you want to get 1 over dx, which is the one we are doing in differential calculus. So there are a lot of lines that you can see in here. You have a line sloping upward, which is a positive slope. What does it mean for positive slope? When it's flat, it's either a maximum or minimum. It's maximum when it is concave down, and it's minimum when it's concave upward. And also we have here sloping down. So when the slope goes down, it means that the curve is going down as well. well. This goes down, that goes up. However, we cannot do this thousand because the line is composed of thousands of points joined together to form the curve or to form a line. What is critical here is when you know the inflection points, that means it's now changing from negative to positive, like this one here. We are on the negatives, and this we are on zero side, and it goes up to positive. But where is it on the line that gives us a very clear, exact position when the curve turns from negative to positive slope? That can be determined by f prime or f double prime. Let's have an example. Before that, let me just show you this one time. Right. So I have here concepts on first derivative of our f or functions that will tell you whether the curve is increasing or decreasing. So when your f is going up, it means your f prime is positive. When it's going down, your f prime is negative, or if it's a constant, your f prime is zero, or if it is flat. Yeah? So what does it mean? Positive means it is curving like this. All right? And then when it's negative, it's curving like that. That's positive, this is negative, and when it is constant, it's flat. Okay, let's have another illustration here. Okay. Now this is the illustration. When your f prime is positive, the curve is going up. Look at the arrow. Yeah, it's going up. When it goes flat, f prime is zero. When it goes down, your f prime is negative. Then it goes flat again. Then so how are we going to illustrate or draw a curve in this sense? If we have, for example, a function of x, which is equal to x cubed, let me just emphasize that by shading it with yellow. If we have a function of x, which is equal to x cubed minus 3x squared plus 5, how are we going to illustrate the curve where you can show the ups and downs of the points approximately? Step one is you have to take the f prime x min time. Okay, let's go straight to the point. So draw the curve of hey, hang on, let's go back there, because if it's not there, if it's not free, then we cannot shift and we cannot freely use the drawing. So here, see, that's technology. Even if technology is very powerful, you still have to do some protocols, which means one must finish on the other. It should not be, overlapping commands. So I have an overhanging command over there, and then I change platform, and then, right, so let's do this one. Step one is take the f prime x. What does it mean? I have an fx equal to x cubed minus 3x squared plus 5 in here. So the next thing you have to do is to do f prime x, or f prime of x. So this is 3x squared minus 6x. The plus 5 here doesn't have any derivative, okay? And then step 2, equate it to 0. So you have 3x squared. Find x values. Oh, this is the one that I was telling last time that you're going to factorize them. So I am seeing here 3x as a common factor, because 3x on this side and 6x is present. There is 3 on one term, there is 3 on the other term, there is x on one term, there is x on the other term. So you can remove 3 as a common factor to both 3 and 6. And then x, you have to remove that. And also 6 is in the 3 times table. You just have to use the smaller number as your reference. If that number, if the other number occurs in that table of 3 or 2, whatever is the smallest, then it means they are both divisible by that number. So you can take them out. I'm saying this even if you are already in the Calculus 1 class, because most of the students do not know how to factorize. So anyway, I have removed 3x from this expression. So it means removing 3x from 3x squared, you still have x inside. So if you multiply 3x by x, it's 3x squared. Because this is minus, I have to put minus here as well. And then you have brought out 3 from 6. So 3 times something will give you 6, so 3 times 2. And x is already brought out. Now, if you're going to test if you're going to distribute 3x to each of the terms, do I get the original? 3x times x is 3x squared. 3x times minus 2 is minus 6x. Okay, so we got the original one. Okay, it's a simple concept, but of course, we need to know and review them if we forgot them. After that, you have to plot your x's. Okay, how do you plot them? Now, I told you last time that when factors are placed in brackets separately, then you can find for x from here. So 3x is one factor, and then x minus 2 is another factor. Equate both to 0, because it says here that one factor is equated to 0, another is equated to 0, so you can separate them by doing what I have in here, and then find for x. If you divide both by 3, x is equal to 0. Here, if you transpose 2 to the other side, then x is equal to 2, thereby having values of 0 and 2 as your point of analysis. So what is the next thing you have to do? Then you have to plot your x's. We are now in step 4. Okay, let this be as my 0, and let this be as my positive 2, and this will be positive infinity, and this is negative infinity. So we have to determine whether they go up or down. So pick values in between and plot positive or negative. That's our step 5. So first off, we have to plot the 0 and 2, which we did already. These are the 0 and 2 determined from the process of equating the factors to 0. Now, we can go like from 2 greater than 2 here. From 3x, hang on, where is it again? F prime, there you go. So if I have, say, what is that? No, 3x, and I have x minus 2. Okay, how you determine the positive and negative? Okay, how would I know that I will have this as slots? First, here you have negative infinity to 0. You have 0 to 2, and you have 2 from 2 up to infinity. So I can say from negative infinity to 0, I can say I will test the number minus 1. Okay, hang on, I'll do like this, because we have already the locations. This is the first one, the second, and the third. Okay, so I will not write that again. Instead, I'll just write here a negative 1 value for x. This is our x. And then from 0 to 2 will be a positive 1. We just have to pick one number in between. And then from 2 to infinity, I will just say 3. I will not go too far. And substitute these values to our x. So if we're going to multiply 3 by negative 1, we get a negative sign. We don't need the value at the moment. And then here you have a negative minus 2, so that will be a negative 3. Therefore, it's a negative sign as well. Next, 3 times positive 1 will give us positive 3. But just get the sign. And then you have 3. Hang on, this is not clear a bit. So we do negative 1 minus 2. So that's minus 3. Still not so clear. So we put negative here. Right, so negative will be the sign. So if you put positive here, positive 1 minus 2, you will get a negative sign. If you put in 3, then that will be a positive 9, 3 by 3, that will be positive 9. And then if you put in 3 to x, 3 minus 2, that will be positive 1. Okay, result. So what will be the sign in between? What will be the sign in between? For my students in Calculus 1, please go to Wonderful Mommy Devs in my YouTube channel. I'm doing my lecture in critical and inflection points, please. This is the first topic that we must have for finals. We should have the face-to-face, but because of the condition, I don't know, in few hours from now, then there will be Gates, Madam Gates. Well, it's not Magat gates will be open. So let's just stay at home, keep calm and keep praying. And if you're not doing anything and you have access to internet, then better open Wonderful Mommy Debs so you can see my lecture in there. You can only see me talking over, but not really the lecture. Kit, Marada, please go to Wonderful Mommy Debs in YouTube, and you can see me lecturing the inflection and critical points, first topic for finals. This is not a coverage of your midterm because I already had given you from A to Z of your midterm scope. This is actually a lecture for finals already. Okay, so, and I'll also be giving you a sit work. It's not a homework, I should say, a homework. And you have to write your answers in your notebook. Okay, so what could be the sign when x will be a negative 1? Obviously, a positive and a positive, if you multiply them together, then it gives you what? It gives you positive sign. The negative when x is equal to 1 and a positive and multiply them together gives you negative. And then the third span, if you have positive and a positive here, multiply them together, you'll get positive. Hence, what is this positive here? It is from negative infinity to 0 is positive. Let me just change that to another. Oh, that's fine, I guess. Hang on. Oh, all right. Here, the one I'm doing now, I'll just change that to a different color. Okay, I'm using maroon. So from negative infinity to 0, we use x here is negative 1. That is our assumption, and we got a positive in here. And then 0 to 2, our x here is equal to 1. We got a negative sign. And then from 2 to negative infinity, our x here value is 3, and we got positive, which means that when it's positive, it goes up. Here is now the curve. Though we are not particular with the inflection point mean time, but we are particular on the behavior. So it goes up like this because it's positive, and it goes negative in between and goes positive again, and we do not know whether it's going down or whatnot. Okay, sorry for my curve. Some parts are flat. They are not. Hang on. Let me just remove it again. Okay, so we do not know where the inflection is, exact inflection, but we know that at this point is positive. We know that this is negative. We know that it goes in that is going to positive again. So that's how it is. But as I've said, there's no inflection point here yet. We do not know actually what point exactly on the curve will change the sign from negative to positive or positive to negative. So, yeah, di po kita yung lecture, ma'am. No, I shared it. It's not here. I told you it's you have to go to YouTube channel. Okay? Bonbon. I was asking you a while ago if you are my student, but you were not telling me. You are not typing in whether you are or not. Go to my YouTube channel. It's not here in Facebook. I am just using the Facebook so that those who are watching right now, I could direct them to the YouTube. Okay, so it's in YouTube that you can see my lecture. All right, so that's what it is for inflections, for critical points. All right, now if you want the inflection, then you have to do for inflection, you have to do the second derivative. Okay, so second derivative for inflection. Inflection is where your line changes from negative to inflection points to positive. Okay, so our first derivative is given to be or computed as 3x squared minus 6x. So f double prime x will now be equal to 6x minus 6 equal to 0. Okay, so if you're going to factorize 6 in here, 6, that will be x minus 1 is equal to 0. Obviously, our inflection would be x equal to 1. Okay, the inflection point is equal to 1. X is equal to 1 here because you have to get, hang on, you have to get this part in here and equate it to 0. We have one bracket, which is x minus 1 equal to 0. Move minus 1 to the other side, you will have x is equal to 1. I hope you understood that. Okay, so x minus 1 here equated to 0. Transpose negative 1 to the other side, you will have x equal to 1. So what does it mean? When x is equal to 1, hang on, it's here. When x is equal to 1, then that's where the inflection point is. You have to, hang on, when x is equal to 1 and y equal to, we have to compute for y as well. So we have, where are we going to get y? We get y from the original equation. Okay, so our original equation, sorry if I'm going to write everything in here. X cubed minus 3x squared plus 5. Okay, let me just do everything in this window. So y is equal to x cubed minus 3x squared plus 5. That is where you're going to get your y. X cubed minus 3x squared plus 5. Substitute 1 to your equation. So y will be 1 minus 3 plus 5. So 5 plus 1 is 6 minus 3, that will be 3. Y is 3. 1, 6 minus 3. Yes, that's correct. Yeah. 1 cube is 1. X squared is 1. If x is 1, then x squared is 1 as well. 1 times negative 3 is negative 3 and plus 5. So 5 plus 1 is 6 minus 3. That will be 3. What would be the values of, or what would be the coordinates of the inflection point? It will be 1 and positive 3. So let's locate that. When x is 1, because this is 0, this is 1, and where is 1 and 3, right? 1, 2, 3. So here at this point, there you go. So it could change from here. So this could be like that, yeah? It was not drawn very well, but that is where it's changing. Okay, that's where it's changing. So yeah, here, so that would be all positive from this point. But when it gets here, this will all be negative. That will be negative. Okay, so yeah, that's all for inflection and critical points. Now, I have something for you to work on. Your homework, actually. So, where will I get that one? Or for your homework, I'm going to just send it to your GC instead. Okay? There's another question here that I want you to do. It's x squared minus 1 square. X squared minus 1 square. Okay, that one. Okay. So you have fx is equal to x squared minus 1, everything square. So this is another question that you can do, um, and draw the curve from here. Okay. So what will you do? You have to get the f prime of x. So this is chain rule. You put the 2 in front and x squared minus 1, the base, 2 minus 1. 2 minus 1 is equal to 1. So you don't need to put the power instead. And then you have to get that, because it's a chain rule, then you have to get the derivative of the one in the bracket, which is a 2x. Okay. Now we have done the derivative. So let's polish it. Multiply. Leave x squared minus 1 like that. We have to simplify it. So there are 3 roots in here. You have, because this is a perfect square, it's the difference of 2 perfect square, which is x plus 1 and x minus 1. If you multiply that, you get x squared minus 1, correct? And equate this to 0. Now here there will be 3 values of x. You have 4x equal to 0, which gives you x. Plot this one, you will have 0 here at the middle, and then you have plus 1 on the right side of 0, and then you have minus 1 on the left side of 0. This approaches negative infinity, and this will be positive infinity. And what will you do next? You have to get values of x negative infinity to negative infinity, negative infinity to negative 1. What a positive 1? Oh, no, it's not positive 1. Negative 0.5. Negative 1 half. Okay. You go halfway. So negative half. And then 0 to positive 1. From 0 to positive 1, that will be positive 1/2. And then from positive 1 to positive infinity, is that you can substitute so that I think we just have to complete this instead, isn't it? Okay, we're going to complete it. What I can do is I can copy this. I can copy this one. I'll put it in the next.